Distance is always measured as the shortest distance between 2 points, which of course is a straight line. In this video, what we're going to be doing is developing the distance formula and then applying it to a couple of problems. All right, so in example number 1, we're going to be plotting 2 points on the coordinate system. You might recognize these 2 points as being the same 2 points that we used for midpoint. Okay, so we're going to go ahead and plot these. We got -4 and 2. That means we're going to go back 4 and up 2. And we also have 2, 10. So we're going to go to the right 2 and up 10. So these are our 2 points. We got A, we got B, and we're going to go ahead and connect those. And our goal here is to figure out what the length of that segment is. The interesting thing about it is that the segment is on a diagonal, which means there's some things that you can't do. You can't just attempt to count boxes across. You can't say like 1 box, 2 box, 3, 4, because all these are all different segments. They're not even like true diagonals of a box. You know, you got like a little piece and a long piece. So you can't count like that. Obviously, we don't want to estimate values. That's not really going to make sense. And of course, the main goal here is to be able to figure out the true distance between any 2 coordinates and not even have to be able to draw them to do it. All right, so what we're going to do, a lot like how I talked about things in midpoint, we're going to separate the ideas between vertical and horizontal. Okay, so let's take a look at the 2 coordinates distance just horizontally here. Okay, so I'm going to cover up everything we don't need to see, just so I can see the horizontal space that's between them. And then we can count these boxes. We've got 1, 2, 3, 4, which would make sense because of the -4 in the coordinate. So you got 4, and then you've got 2, which comes from the 2 in the B coordinate. So altogether, we got a total of 6 as a space here. Okay, now you can't use that just to represent the distance because it's only a horizontal distance, and it would only measure from here to there, which is obviously shorter than the segment we got. Okay, but we can do the same thing vertical, right? If you look at them vertical, we're going from a height of 2 to a height of 10, which is going to count as 8. 1, 2, 3, 4, 5, 6, 7, and 8. So you get a height of 8. Okay, now that one seems a little bit closer to what the length of this would be, but it's still going to end up being shorter than what that one is. Okay, so now we got to think is, all right, there's 2 measurements that we can take, but neither of them are going to really represent the length of that diagonal. What I'm going to do is highlight those 2 segments, or I'd highlight 2 segments that represent what I was just talking about. Okay, so that's a height of 8, the same height that I think I actually counted there. Okay, and this is the horizontal distance between the 2 of them that I had counted the 8. And when you take a step back and you look at this picture, you realize something. That with the diagonal and with the vertical and horizontal components, that's what these are actually called, the horizontal and vertical components from A to B, we actually have a right triangle. And if there's one thing that you've learned about right triangles, is that we can use the Pythagorean theorem. I mean, literally anytime a right triangle pops up in a problem, that should be your first thought is like, okay, Pythagorean theorem, is there anything I can do with that? And that's exactly what we can use this for here. Remember that this side right here is a length of a 6. This right here is a length of an 8. And this is what we're trying to figure out here. It's a little question mark there. We're trying to figure out that side. Okay, so with Pythagorean theorem, what it says is that in any right triangle, and yes, it has to be a right triangle, in any right triangle, if you take the sum of the squares of the legs, that would be the vertical and the horizontals, then that's going to be equal to the square of the hypotenuse. So the sum of the squares of the legs, that's going to be 6 squared plus 8 squared. That's going to be equal to the square of the hypotenuse. And I just put a question mark there, but let me just write in here an x, because that's our unknown value. Okay, so 6 squared plus 8 squared has to be equal to the hypotenuse squared, which I'm calling x here. So you've got 36 plus 64 is equal to x squared. 36 plus 64 is going to add up to 100 So 100 is equal to our hypotenuse squared, which means that if we square root that number to get this down to x, we get 10 is equal to x, and that's the length of the hypotenuse, exactly 10. Now here's a cool thing that you can check out. If you actually do this on grid paper where it's true grid paper, and by that I mean obviously it was at least printed, you didn't draw it on your own, but mostly if these are called steps here actually, but the spacing between any vertical lines, if that spacing is the same thing, the same length between the spacing vertically, you're going to end up with a true grid here. And my claim is that, based on Pythagorean theorem, my claim here is that this is 10 units. Okay, so I'm going to take a piece of paper I have here. This is actually cardstock. Take this piece of paper, and from the corner, I'm going to measure 10 units. Okay, so 0 to 10. I'm going to measure 10 units because that's what I think the hypotenuse is. When I take that and I hold it diagonally here, you're going to see that it matches up perfectly. Okay, so all the work that I've done here is enough to get us to create a formula for figuring out distance in the coordinate plane. Okay, so this is our distance formula. Now, when you look at it, it does look a bit complex. There's a lot of things that are happening in here, but these are literally all the pieces that I did to do the work here. Okay, so I'm going to really highlight the point here that the distance formula is taken from Pythagorean theorem. Because if you can remember that this is Pythagorean theorem, you can actually cut a lot of corners in how you approach answering different distance problems. Okay, some things we'll kind of work from the outside in to understand what's going on. The very last step that I did here was a square root. I had to square root all my other calculations to get down to just the length of the hypotenuse, which would be the diagonal between the 2 points that are connected. Okay, so you're going to see the square root is the very last operation that's here. All right, preceding that, we had a couple of numbers that were added, and those numbers were taken from 2 that had been squared. Okay, so there's your addition. In front of the addition and after the addition, we do have things that are being raised to the second power. Okay, so this right here is actually the 6 squared. This is the 8 squared, and they're being added together. Then at the end, you would end up doing a square root. Okay, so now how does this represent the 6? How does that represent the 8? This is the difference between the x values. Okay, so the x values that we had were -4 and 2. So if I take -4 and subtract 2, I actually end up getting -6. I don't get 6, but I do get a -6 if I subtract those two. Of course, if I flip it backwards and I did 2 minus -4, if you do 2 minus -4, that actually becomes 2 plus 4, which is 6. So depending on the order, you can either get a -6 or you can get a +6. The same thing is going to be true with the y values. If you do 2 minus 10, you get -8, but if you do 10 minus 2, you're going to get +8. So does that really make a difference in the calculation? Not really. Because whether you get a -6 or you get a +6, when it does get squared, it's going to turn out to be a positive number. So if you multiply a negative by a negative, like -6 times -6, it does turn out to be positive 36. So it does work itself out here. The thing is when you're using the formula, you've got to be really careful about watching the negatives, make sure that you add when you should be adding, subtract when you should be. That all comes down to whether or not there's negatives in the problem. This part does get a little bit tricky when you're doing them, so just be very careful that you label your coordinates as x1, y1, x2, y2, and you place everything where they should be. Okay, when we do the example that's coming up, I'm going to show you exactly with the distance formula, and then after that I'm going to show you how I just use the concept of Pythagorean theorem to get the answer done. All right, so in example number 2, we're going to be figuring out the distance between these 2 points. Okay, and you'll see here to the left, I've already got almost all the work. I just haven't finalized it. Got almost all the work for using the distance formula, just so they can have that. But then to the right here, what I'm going to end up doing is showing you my method for actually doing this, which is going to look pretty close to it, but I think it takes out the messy parts at the beginning. All right, so you should recognize the outline, right? You've got square root, you've got x1 minus x2, or maybe it's 2 minus 1. It doesn't really matter as long as you're subtracting them, and then you've got the difference in the y's over here. Okay, so the thing that you really want to be careful with here, though, in distance formula, it's not going to cause you to get any bad answers, but if you're going to be using the formula, I want you to practice something, because it will be important when we talk about slope. It'll absolutely be important there. Okay, and what that is to make sure that you're aware of which coordinate's going to be your coordinate 1 and which one's going to be your coordinate 2. Okay, so for my x's, you're going to notice that I have 5 minus negative 1. Okay, so I'm taking that x and subtracting this one. And yeah, if you have 5, the formula says that it's going to be the difference in the x's, you got to subtract them. So it is going to be 5 minus a negative 1, which is going to turn out to be 5 plus 1, which gives you 6. Now, if I choose to do 5 minus negative 1 and not the other order, then you want to use the same order for your y's. You want to do 2 minus 3, which will give you negative 1. Now, again, in distance formula, if you mix it up, it's not going to make a big difference. It's not going to make any difference, because when you square them, whether you're squaring a positive number or a negative number, they both come back as positives. But later, in our next topic, which is going to be slope, if you start mixing up the coordinates, you're not paying attention to which one you start with and then which one you subtract from it, it gives you backwards answers. That's the easiest way to put it. You have backwards answers which are wrong. All right, so we do get 6, we do get a negative 1. They do get squared, you get 36 and 1. Those are going to add together to give you 37. And 37 is not a perfect square like 100. So the first example, I definitely wanted to show you a perfect square so I could verify using the cardstock that it was true. Many cases, most of the cases that you do with Pythagorean theorem are not going to be perfect squares at the end, which means that we'll just go to a calculator and evaluate that last part. Okay, so I'm just going to take the square root of 37, which is going to give me 6.08. Okay, and that's an approximate answer that we have here. Approximately 6.08. We should use the approximate symbol versus the equal. Sometimes I'll mess that up, so just be aware, but it is approximately 6.08. All right, now off to the right. The way that I actually do the problem. So I like to demonstrate, here's how you can use the formulas, because a lot of people like to use them, but I also like to demonstrate if there's other methods to do things, because I like to think that most of the methods that I use are still based in what the formula comes from. All right, so if I'm thinking about these two coordinates sitting on the grid, so imagining what we did at the very beginning, where we drew the right triangle. If I imagine the two coordinates sitting on there, the two main things I need to figure out is what's the horizontal distance and what's the vertical distance. Okay, so the horizontal distance is just the space between these two numbers. So if I'm literally just thinking of these two numbers on the number line, I should be able to figure out what the space is between them. One of them's a negative, one of them's a positive. So you imagine the number line, you'd have -1, then it would go to 0, and then 1, 2, 3, 4, 5. So there's a total space between these of 6 units. For the y's, this one's a really easy one. How much space is there between 3 and 2? It's 1. Now, here it turned out to be a -1, which squares and becomes a 1. But look what I did. Just looking at the numbers that were given and considering them on a number line and saying, well, how far apart are they? I get the 6, I get the 1, which is good enough to get me all the way to this point here. Now, this is all me remembering that this comes from the right triangle that we drew. There's a horizontal line of 6, there's a vertical line of 1, and then I can use these as the legs of the triangle to square them. And of course, well, you know the rest. The square root of 37 is approximately 6.08. And that's the approach that I take at doing these. So you have your choices. You can do this. That's fine. It works. It's a real formula, and it's good to practice formulas. If you get the concept, save yourself a little bit of time and try that out. Example number 3 is definitely going to be the challenge problem for the notes here. In example number 2, you were given 2 coordinates and asked to figure out the distance between them. That is what I describe as like a forward working problem. Okay, more of an evaluating problem. Example 3 is your backwards problem or your solving problem. What we have is the end result. We know that there's 2 coordinates that are going to be 5 units apart. You get 1 coordinate complete, there's 3, -5, and then the other one's only partially complete with the 7 and then the unknown y value. For this, I'm definitely going to stick to the concept of Pythagorean theorem to answer. Because if you go with the formula, you're going to attempt to plug these in to as many spots as you can here until there's one empty spot where the b goes, and that's going to be one of the y's. So one of these would end up being the y, or the b value that would be in the equation, and the whole thing would be set equal to 5. Starting from there is doable. It's a bit confusing and messy, and if we think about this as Pythagorean theorem, we can save ourselves a lot of time on here. Okay, so thinking Pythagorean theorem, we got, I'm hesitant to use a squared, b squared, c squared, because you know that is Pythagorean theorem. Here, let's just use a couple different letters so I don't get it mixed up with the b. Let's say that it's x squared plus y squared is equal to z squared. So still Pythagorean theorem, I just swapped out the letters so we don't get confused with the b sitting in that spot there. Okay, so this is my template that I want to work with. The z would represent that hypotenuse, and the 5 being the distance between the coordinates would be that hypotenuse. Okay, so I know that this part's going to be a 5 squared. These I don't really know yet, but because I have both of the x's, I can consider the distance between these 2 coordinates. So from 3 to 7 is a 4, and that will give me this value here. I get a 4, which of course will get squared. Now this is the part that is unknown at the time. Okay, so I'm just going to call it plus y squared. Keep that in there because I don't know what to do with that. That would actually be the difference between -5 and b. Of course, I can't figure that out. But let's see what we do have. 4 squared is 16. 5 squared is 25. You can subtract the 16 from the 25, and we get y squared is equal to 9. 25 minus 16 is 9. Now, we'll square root it to get it down to just y, which is 3. Square root of 9 is 3. So that tells us that the space between -5 and b has to be 3 units. So what would that answer be? Or what would those answers be? This actually has 2 answers to it. Okay? B just has to be 3 units away from -5. It could be greater than -5, it could be less than -5. Okay? So it could be -5 plus 3, which is going to give you -2. It can also be -5 minus 3, which is -8. You actually have 2 different answers that could work for this. All right, so let's take a look at what those answers would be. So I hope mathematically you see that, okay, yeah, if the space only needs to be 3 from it, then we can go in either direction. But what would that look like on the grid? How do we verify that that's good? Okay, so this is going to be a rough sketch of what this would look like. The coordinate that we do have, the 3, -5. So I'm going to go out 1, 2, 3, 1, 2, 3, 4, 5. That's going to be that point. Okay. The other thing that we do know is that our other coordinate is going to be at 7 something. So that's 3, 4, 5, 6, and 7. Has to be at 7. Okay, and then what I'm going to do is I'm going to draw a little dotted line here. Okay, and the height on that dotted line is B. So one of our answers tells us that it's going to be at -2, which is here. The other answer is at -8, which is here. And this is what our picture looks like. Because we don't know what B is, right? When we start from that point, we can either go over 4 and up 3, or we can go over 4 and down 3 to the point. But both of these will give us a length of 5.
Wait, there was.